Okay, class, today's lesson is on factoring special trinomials, or as I say, special factors. So the types of trinomials you're going to factor are the ones that factor as difference of squares, the key being the word difference, which means a subtraction, and also that their signs are different. Okay, or perfect square trinomials, which will be exactly the same, like x plus 2 times x plus 2, and so that equals x plus 2 all squared, and that's what you have to write to get full and complete marks. And we'll talk about how to recognize them and do them in the short form. For the difference of squares, it would be like x plus 2 times x minus 2, and the signs are different in between them, so they're not quite perfect. All right? So we're going to talk about difference of squares to start. The first thing is, what you got to recognize is that you have a binomial. So you have two terms in the product. All right. The reason why is because when you multiply this out, from this multiplication you get minus x times y, or minus xy. And from this multiplication you would get a plus xy. And so that net result cancels to 0, and so there's no middle term. You get x squared at the front from the first multiplication and a minus y squared at the back from the last multiplication. And so the green is what's left over. These guys cancel each other out and they will be gone. That's why we're left with the two-term binomial. Okay. So what you got to notice if you're looking at algebra tiles is you would have a perfect square. So this length and this length are exactly the same, but what's different is the shading of the one tiles. And what you'll notice, that gives this a plus 2x and this a minus 2x, which cancel out. You'll also notice that this one tiles are a perfect square. Now, we have 2x, but you could have something different. For example, you have plus 3x minus 3x, or maybe plus 8x, and then you'd have a minus 8x, and middle terms would cancel out. So when we're looking at this multiplication, we would get x squared, and then, we would get x squared minus 2x. Then from this multiplication, you would get plus 2x, and the last multiplication, you get minus 4. And so these would cancel out, and you get x squared minus 4. You'll notice that you must have a subtraction there. And that's because you have two opposite terms being multiplied, giving you the product, which is a negative number. Okay? So what we do is we can use what we know with the pattern going with the multiplication to work backwards with the factoring. So what we do is we break this apart into 2x and 2x, and those go at the front of the brackets. And then we square root the back, but we leave the negative sign out of it, and we get a 1 and a 1. And because of this being a difference, we have to have different signs. So we go plus minus. Or, of course, it doesn't matter where you put the signs. You could have 2x minus 1 times 2x plus 1. These could flip-flop. That doesn't matter. But inside the brackets, you must have the same thing. Okay. So don't worry about using the algebra tiles. We won't do any algebra tile stuff for the factoring. So we're going to square root the first term. And so that answer is 2b. And so we get a 2b at the front of each set of brackets. And then we're going to factor the second one. What's the square root of 121? That equals 11. And so we get that at the back of the brackets. Last step is plus minus. Okay, so let's square root this one. Can we square root it? Ooh, root 6. What does that equal? Well, you'd have to go to your calculator. That means you got to take out a GCF first. So let's take out a GCF of 6. That would go up front. Your remainder goes in brackets. X squared minus, I don't know what that is. So I will go and use my calculator. I don't know what that happened there. 150 divided by 6. and we get 25. And we know that's right because that's a perfect square. So how would we factor x squared minus 25? Well, at the front, we would square root that to give us x at the front. Square root the last one to get 5 at the back. And what's our last step? Plus minus. Now remember, we have 1, 2, 3 factors. Okay. And what led us to the 3 factors? Well, these are not perfect squares. Okay, or not squares. So GCF first. If you ever get some weird questions, look for your GCF. Let's look at the next one. 32 and 98 is not, those are not squares. So we're going to look to take out a GCF. Now looking at the letter, we can definitely take out the letter M. 32 and 98, I'd say I want to try 4. Nope, I'd say maybe 2. So if I take out a 2m, well, what's going on here? If I take out a 2m, sorry, let me get rid of this. Oh man, what is happening? If I divide by a 2m, I would get 2m up front, 16m squared. Excuse me. Minus, gotta go to my calculator, so I'm going to do that. Okay, so I go 98 divided by 2. I get 49, which is another nice number because those are both squares. So now I need to go and square root them. So I will square root the front and the back. So I get 4m at the front, 4m at the back, and then I get 7 and 7 plus minus done. What am I forgetting? You're right, the GCF. Don't forget your GCF. I have 3 full complete factors. Okay, next one. All right, I'm done. I know I'm done right away. You know why I know I'm done? Because I'm going to write this down. Not factorable. Do you know why this one is not factorable? There's 2 reasons. Number 1, there's no GCF. Now I gave you some juicy numbers like 25 and 16, which are squares, but it's not a difference of squares. And the reason why it's not a difference of squares is because simply there's an addition. And why does that matter? Because addition is not a subtraction. And in order to have difference of squares, it must be a difference, it must be a subtraction. And so because of this, right here, it is definitely not factorable because there is a plus sign and it needs to be a subtraction. Okay, here's some harder ones. If you're an expert, go for it. If you're ready to do your homework, do your homework. Here, I'm going to square root, and so I'm going to get 12y minus 9z, 12y plus 9z. So you got a letter in the front and the back now because of the z part. No big deal. Next, you have an x squared part. So what's the square root of that? Well, square root of x4 equals x squared times x squared. So it simply equals x squared. Okay. So I would get 9x squared minus at the front and minus 4 plus 4. But I'm not done yet. Do you know why? Well, because this is another difference of squares. So that one can be factored one more time. Perfect. The square at the front is 3x, 2 and 2 plus minus. What about the 9x squared plus 4? I just told you you can't do it because it's not factorable since there's a plus sign. And so you have 3 factors and you absolutely must rewrite and identify that last factor. Okay, so here's the trinomials, some more harder ones. So I'll be doing sum product. The product is 16, the sum equals -17. So it'll be 1 and 16, 2 and 8, 4 and 4. But in order to get sum of -17, I would have to have these two as both negative, which is good because that multiplies to the plus 16. Now a little bit of trick. Because I have a4, that means I have a squared at the front of each one. And then I have -1 minus 16. Am I done yet? No, I'm not done yet. So here's a little tricky one. This one, you can square both parts, square root both parts. So this would be an a at the front, and the weird question, 1 and 1. So the square root and then square root. And the square root of 1 is 1. I know, it's a little wonderful, that question. Well, the next one, can you factor it further? Absolutely. So a's at the front, 4's at the back, plus minus. How many factors altogether? 1, 2, 3, 4. So this one has 4 factors. So you're going to see this under the section that says factor completely. That's your hint that you got more than one step and that you're going to probably have to do GCF first, then some other factoring, or more than one factor step. Okay? Okay, so for our last question here is definitely a challenge question. Definitely honors grade 11. So what we say is we say A equals, or X, whatever letter you want, you're going to have to do a substitution. So let's say X equals 5m minus 1. So then we put that in for 5m minus 1, and we get x squared minus 36. So then we do difference of squares. We get x plus 6, x minus 6. And then what we have to do is we then have to go and substitute this back in. And so we get 5m minus 1 in brackets plus 6. And we get 5m minus 1 in brackets minus 6. And so then we can go and drop our brackets, and we get 5m minus 1 plus 6, bracket, 5m minus 1 minus 6, bracket. So this one we get 5m plus 5, and this one we get 5m minus 7. So this is definitely like honors / grade 11. All right, we have to do a substitution, factor it, and then do another substitution. That'll be a bonus on the test. Okay, last little bit. Okay, so this here would be a bonus question. Any style like that, absolutely. And these other ones for this page, 5, 6, and 7, you'll probably see 2 of them on your test, max. Okay, so you're not going to see a lot of them. Perfect square trinomials. So these are trinomials with 2 identical factors. So for example, here you would factor this out and you would get the same factors, and then you would write for this for full marks. Okay, so if you left it here, this would be half marks. Okay, half marks here. And for full marks, you would then have to go and write it the whole way. So a lot of your questions are going to be, is it a perfect square trinomial? So you can cheat. You can actually go and factor it and see. But there's another way. You'll notice when you multiply this out that you would get 7a plus 7a. So what you can do is you can divide that by 2, and then you can see, well, is 7 one of the factors? Does this square root 49 equal 7? Yes, it does. So then you know you have a plus 7 squared. So the trick to do this quickly is you would multiply those together. So 7 times a, which is 7a, and then you would double. Okay, so you could multiply, and then you would double. And so you would get, sorry, let me write that double a little bit further down. You would get 14a. Okay. So this one here, a plus b squared. If you look at this, you get a plus b times a plus b. So you would then get a squared plus ab plus ab. So there's two of them, plus b squared. So they're being multiplied together, and you double it. So a squared plus 2ab plus b squared. So I'd multiply them together, and that would give me my ab positive, and then I'd times it by 2. I'd double it to get the 2 plus 2ab. So let's try the shortcut with the next one. Multiply a times negative b. That gives you negative ab. Then double it. And so you get negative 2ab in the middle. So I'd square the first term. I'd have multiplied together and doubled, and I'd square the last term. Okay, let's see if this works out. I'll show it the long way now. And here's the other trick, fellas and ladies. If you want and you're unsure, write it out the long way. It's okay. So multiply, you get a squared minus ab plus b squared. Okay, it's always a plus. And that's because you'd have to have the same terms. Okay, it's always a positive slash plus. Always. And so this would be a squared minus 2ab plus b squared. All right. So looking at that, there you go. That's kind of in a nutshell, but you can always cheat. The middle one is multiply them together, double it. So let's just look here, factoring this here. We won't worry about algebra tiles, but your product equals 25 and your sum equals 10. So 1, 25, 5, and 5, and the only way to get 10 is with these ones. So we would get a plus 5 times a minus, wrong, a plus 5, and so a plus 5 all squared. Okay, which of these are the following perfect square trinomials? If not a perfect square, why not? This one isn't, because it must be a plus 25. And okay, it's the only way it works out. So this one is not a perfect square, because in order to get a negative, if you had a perfect square and you had a minus 5 times a minus 5, that would give you a plus 25. Or if you had a plus 5 times a plus 5, that would also give you a plus 25. So it must always be positive. This one here, it could be, so what I would do to double check is I'd divide that by 2 to get 6. And then I could double check here. If I square root that, I would get 2x. And if I square root this, I would get 3. So 2x minus 3. I'm thinking about that. Multiply those together, I get negative 6x. Then I'm going to double it. Negative 12x. So yes, meets all the requirements. This is a positive, and the middle term is doubled of the two outside terms. This one here, I think so. Let's square root that. That would be 2a. And this would be plus 4. And so I'd multiply that together to give you 8a, then double it to get plus 16a. And so no, because this should be a 16a. Okay, so it's not proper, it's not a perfect square. This one here, square root it, that would be 7x. Square root this one, I'd be plus 5, or it could be a minus 5. And looking here, we think it's a minus 5. So let's multiply those together, negative 35xy, and then double it, negative 70xy. So yes, it's a perfect square trinomial. Okay. There we go. Done, done, done.